Okay, let's take a look at what are called linear inequalities. So first thing you want to notice is that we have an inequality sign here, okay? And over here in this problem, there's an inequality sign also here. So these are not equations. Also, it's linear because the highest power on x we have is the first power, and that's the same with this problem here. So let's take a look at this first one. What we're going to want to do is get x on one side of the inequality and then a number on the other side, just like we would do with an equation. So I have 3x over here, I have negative 2x here. I'm going to go ahead and add 2x to both sides. And I'm also going to add 5 to both sides because that will get rid of the number on this side. So the 5's go away here, the 2x's go away here. On the left side we have 5x. On the right side we have 6 plus 5 is 11. So we still have our inequality, 5x less than 11. Now we divide both sides by 5. So x less than 11 over 5. So all the solutions to this linear inequality are any values of x that are smaller than 11 over 5. So on a number line, if you look at 11 over 5, that's some number, we're looking at everything less than it and not including that point. So I'm going to put an open circle there. In an interval notation, the answer would be negative infinity to 11/5 with a parenthesis because we do not want to include the endpoint 11/5. And then of course negative infinity because it goes this way forever. Alright, let's take a look at this problem here. Okay, for this problem I'm going to do something just to show you something special about linear inequalities. I'm going to get my x's on the left side and my numbers on the right and just see what happens. So I want to get rid of the 13 here, so I'll subtract 13 from both sides. I want to get rid of the 10x here, so I'll subtract 10x here, subtract 10x here. So the 13's are gone, the 10x's are gone here. 7x minus 10x gives us negative 17x, greater than or equal to, on this side, negative 17. Okay, now here's the very special thing about linear inequalities. Anytime you multiply or divide both sides of a linear inequality by a negative number, you have to flip the inequality sign over. Now if you go back over here, when we divided through by 5, 5 was a positive number, so I did not flip this over. But in this problem, when I'm dividing here by negative 17 to get x by itself, what's going to happen, these are going to cancel. I'm still going to get the x here, but now this inequality sign will flip over. It'll become x less than or equal to instead of greater than or equal to. Over here, negative 17 over negative 17 is just 1. So on a number line, all of our answers, if we look at the number 1, is everything smaller than or equal to 1. So I want to include a solid dot here. In an interval notation, that's everything from negative infinity all the way up to 1, and this time I use a bracket because I want to include that point.